Okay, in chapter 2.4, we're working with formulas and percents. So let's start off with doing a couple problems from the chapter review on page 204. So let's look at problem 32. It says I equals PR, and it wants you to solve for R. So solve for R. I need to solve for R. Okay, so which means it doesn't matter if I'm using letters, variables, numbers, doesn't matter what's going on. I'm still going to do the opposite of whatever something's doing in order to move it. So let's recap. What's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. What's the opposite of subtracting? It's adding. And what's the opposite of dividing? Multiplying. So it doesn't matter if I'm using variables, which are letters, or if I'm using numbers. I'm still going to move everything the same way. So for the first problem, number 32, I'm solving for R, which means who's in R's territory? Who's literally hanging out on R's side of the track? Side of the track. So let's see, who is it? It's P. And what's going on between P and R? They're multiplying, which means in order to move something that's multiplying, you are going to divide by P. Divide by P. You end up with I divided by P equals R. And that's it. You just solved for R. Good job. Let's try another one. Oh, this went away. Hold on. Let's try number 36. So we have T equals D plus PM. And it says solve for, what letter are we solving for? M. So my goal is to get everything away from M. So I've done this problem before, but the only difference was I used numbers. But I'm still going to do the same thing. I have a P hanging out with M, and I have a D. But who do I need to move first? I'm going to move the D. What kind of D is it? It's positive. How do I know that? Because I don't see a negative sign in front of it. And how do I move something that's basically adding? I subtract it. So I'm going to subtract D on the right side as well as on the left side of the equal sign. Now, this says T minus D. T and D, they're not like terms, so I have to leave it as T minus D. Equals, well, D minus D cancels out, and I'm left with P, M. And I'm still solving for M, which means now I can move P. What's going on between P and M? They're multiplying. And what's the opposite of multiplying? Divide. So divide by P. Divide by P. What you do on one side, you have to do on the other. The P's cancel here, and I'm left with M equals T minus D divided by P. And that's it. Good. Now let's see. Let's look at problem. How about 38? Problem 38. And it says 90 is 45% of what? 90 is 45% of what? So in this problem, I'm looking for the what, which means this is basically English. It's speaking English to me. In order to solve, I need to translate it to math. So let's see if we can remember some key words, some key English words, and what do they translate in a math language? What's the math language? So is, what does is mean in mathematics? Yep, it means equals. It means equal. What does of mean in mathematics? It's multiply. And what, well, actually, what is what in math terms? It's a variable. I'm going to call it x. So I'm going to take this sentence, I'm going to read it, and I'm going to write it as I read it. So this says 90 is, well, what's is in math? It's an equal sign. 45%, well, I'm going to change that 45% into a decimal. So it should be 0.45. Of, well, of means multiply. Multiply by what? X. So 90 equals 0.45 x. And it's going to tell me to solve, right? I need to solve for the variable. So I'm going to solve. Well, what's going on between the 0.45 and the x? They are multiplying, which means how do I solve for x? I'm going to divide because that's the opposite of multiplying. So 90 divided by 0.45 is going to be 200 equals x. So 90 is 45% of 200. Good. How about we also try number 40? Alright, so number 40. It says the following. If 6 is increased to 12, the increase is what percent of the original number? So I'm looking for a percent increase here. Now I like using a different formula than the book. My formula is new minus old divided by old times 100. New minus old divided by old times 100. Okay, so let's see here. It says if 6 is increased to 12, so 6 is the old number and 12 is the new number, so I have 12 minus 6 divided by 6 times, I'm going to use a dot, 100. The times 100 makes it a percent basically. Matter of fact, I'm going to use parentheses. Times 100. So 12 minus 6 divided by 6 times 100. The formula says new minus old divided by old. So let's see. 12 minus 6, well, that's going to be 6 divided by 6 times 100. Well, 6 divided by 6 is 1. So this ends up being 100% increase. Okay. So with chapter 2.4, we have basically formulas and percents. We start off with still solving equations. You're still solving equations right here. The only difference is you're dealing with all variables. Okay? Same with 32 and 36 are the same. 38, you got to work on translating from English to math and vice versa, from math to English. And then 40, remember this formula, new minus old divided by old. That gives you percent increase or decrease.